Welcome to Study Loop.
Hello everyone, here it is given a cylinder uniform rod AB of mass m and vertical shaft CD, each of length 2b, welded at midpoint. So length of AB and length of CD is both are same and mass of AB is given m. They are welded together at midpoint G. It is initially at rest, so initial angular velocity is 0. When couple of moment is applied on the shaft CD, so moment m naught on CD is given, that is m naught G cap. Calculate the resulting angular acceleration of the assembly. Alpha we have to calculate. B part, dynamic reaction at C and D. C and D, that we have to calculate. Let us start solving it using the principal axis. I x dash x dash y dash z. This is your x dash and this is, I am drawing with blue color. This is your y dash. So this is your x dash and this is your y dash. Start calculating now. Using the principal axis, G x dash y dash z. I x dash is 0. I y dash is equal to I dash z, sorry, I z to be equal to 1 by 3 mb square. Omega x dash you can resolve into its component. It will be minus omega sine of beta, omega y dash, omega cos of beta, and omega z is 0. Angular momentum about G. Hg, if we find, it will be I x dash omega x dash I cap, I y dash omega y dash j cap plus I z omega dash z k cap. Now this is 0, so this term becomes 0. This is mb square by 3 omega cos of beta j cap, and the omega z is 0, so this becomes 0. So from here you can write angular momentum about G would be half one third mb square omega cos of beta into I. J dash can be written as, this is actually J dash, Let me correct it. J dash can be written as I sine of omega t plus j cos of beta. You are resolving it. Solve it, so you will get angular momentum about g in terms of x-axis, y-axis and z-axis 1 by 3 mv square omega cos of beta sin beta I cap plus cos beta j cap. Say this is equation to be 1. Now rate of change of angular momentum, rate of change of angular momentum about g, h dot g can be written as a rate of change of momentum about the gxyz plane plus omega cross as this is 0, sorry, this is not 0, this is 0 because just a moment, cos of beta sin beta I cap plus cos beta j cap. This is your second equation. This term is 0 because omega is 0 or omega is 0 with initial angular velocity. Equation of motion we will apply equivalent of applied and effective forces, equivalent of applied and effective forces, summation of moment of force about d point will be 2bj cross cx I cap plus cz k cap plus mo j cap is equal to 1 by 3 mv square alpha sin of beta cos of beta I cap from equation 2 1 by 3 mv square alpha cos square beta j cap. solving and equating the coefficient of I cap, j cap, k cap. So equating the coefficients of I cap, j cap and k cap. We can write for I cap, it is 2b cz to be equal to 1 by 3 mb square alpha sine of beta cos of beta. Say equation number 3. For j cap, you can write moment of couple about O will be 1 by 3 mb square alpha cos square of beta. This is fourth. And k cx to be 0. This is your fifth equation. From equation 4, we can find angular acceleration. So angular acceleration to be 3 m naught upon mb square cos square of beta. From equation 3, Cz will be 1 by 6 of mb alpha sin beta cos of beta, that is substituting the value of alpha here. From this value you can write and simplify, you will get 1 by 6 mb sin beta cos of beta 3 m naught mb square cos square of beta. So solving it, Cz you will get m naught upon 2b tan of beta. Cx already we have find, it is 0. So summation of force must be 0, that is C plus D is equal to 0. Hence D force is equal to minus C reaction force at the coupling. So C force can be written as m naught by 2b tan of beta, that is k cap, and D force is m naught by 2b tan of beta. This will be minus k cap. So this is the answer of B part of this problem. Thanks for watching it.